Hi there, this is Professor Shannon Gracie working out of Sullivan and Sullivan's text, Precalculus Enhanced with Graphing Utilities. So today we'll be covering the second part of the systems of linear equations, and this part deals with the applications. So here we go. First one, we have the length of a fence required to enclose a rectangular field is 3,000 meters. What are the dimensions of the field if it's known that the difference between its length and width is 50 meters? So you have to decide what kind of information you've been given. So the first sentence gives us what kind of information? Great, it gives us the perimeter measure because the length around a polygon is perimeter. So let's check it out. So we have, a rectangle, and we could let L be the length and W could be the width. And we know that the perimeter is 3,000 and the perimeter is 2L plus 2W, which is 2 times L plus W. What else have we been given? Great, we've been given that the difference between the length and width is 50 meters. So since the length came first and the width came second, that means that the equation would look like this. Oops, kind of a crazy L. Okay, so far? Great. So the second step is to, translate to an equation. Translate to math. So we've already got a lot of it done. Let's put together these two parts and say double the length plus the width is equal to 3,000. So in turn, that will give us, if we divide both sides by 2, we will have the length plus the width is what? Good, 1,500. And then we also have L minus W is 50. So this here is our system of equations. And solving, if we call this one A and this one B, so solve the system. So basically, for step 1, all we're going to be doing is we're going to add A plus B because we have opposing coefficients on the W's. And that'll enable us to solve for the length. So L plus W is 1,500. L minus W is 50. And adding, we will get 2L is equal to 1,550. And then dividing both sides by 2, let's see, 2 goes into 15 7 times, so 775. Okay, so far? Good. Now, what would our next step be? Good. We just need to pick one of the equations, and we're going to substitute L equals 775 into which equation? It doesn't matter. Why don't we do equation B looks good. Okay, so here we go. L minus, having trouble with my L's today. L minus W is 50. We found out that L was 775. And so negative W is negative 725, and W is 725. So for our conclusion, they asked us for the dimensions. So here we go. The dimensions of the field are 725 meters by 775 meters. And you're all set. That probably seemed easier after those 3x3 systems. Or, yeah, 3 by 3 linear equations, 3 unknowns. Okay, so next up, what do we have going on? A movie theater charges $9 for adults and $7 for students. On a day when 325 people paid an admission, the total receipts were $2,495. How many who paid were adults and how many were students? So please, if you feel confident, pause the movie and try this on your own. Otherwise, you can go along for the ride. So what would we have for our analysis piece? A lot of times when you name your variables, just look at the last couple questions. So we could say let x be the number of adults who paid admission. And let, oh, it helps if you actually write the variable. There we go. And let y be the number of students who paid admission. Okay, so let's go ahead to the translate portion. So we have some information. One piece of information we have is, good, we know how many people paid for admission, right? So why don't we go with that one first? So how many people paid admission? Great, 325. And there are adults and students who paid admission. So that's our very first equation. And then the total receipts were $2,495. So now we're talking about money. And so we have to put the valuation of the adult ticket and the student ticket. So the adult ticket, if you remember, was $9. So 9 times the number of people is the total dollars spent for adult tickets, and $7 for the student tickets. And there we have our system. So if we name this guy A and this guy B, then solving the system will be easy peasy. So let's do it. What would you guys like to do? Do you want to do substitution or elimination? Let's do substitution in this one. So the first one, I'm going to go ahead and isolate y in equation A. So we have x plus y equals 325. So subtracting x from both sides, we'll get y is equal to 325 minus x. And then since we used a to isolate the variable, we need to use that equation here, or expression for y, in equation b. So substitute y equals 325 minus x into equation b. And that will allow us to solve for x. So equation b is 9x plus 7y is equal to 2,495. So we found out that y was 325 minus x. So we'll have 9x plus 7 times 325 minus x is equal to 2,495. So all I did is, and for y, I put 325 minus x, which I got from part I, or 1, I guess. Okay, so then, let's see what we'll get. So we'll get 9x plus, let's see, what's that going to be? 35, 17, I believe 2275 if I did the math right on that. You know, it's been one of those days, so let's check Mrs. Gracie's work on the graphing calculator. So here we are, 7 times 325. There we go, 2275. And then we'll have minus 7 x's is equal to 2,495. So 9x minus 7x is 2x, and when I subtract 2275 from both sides, I will get, again, I don't trust myself today, so I'm going to subtract 2275. Oh, that's what I did on the first one. See, I told you, I'm just all ready to make up my own math. 2495 minus 2275. Enter. 220. And therefore, x would end up being 110. And we'll go ahead and we'll check this at the end of the day. So third step would be substitute x equal to 110 into equation. Which one should we do? Just do the first one. X plus y is 325, equation A. So we had x plus y is 325. So 110 plus y is 325. This is what we had gotten for x. And that would leave y to be 215. So let's check in the original. So $110 for x plus 225 for y gives us, oh, 335. Oh no, it was 215 for y, wasn't it? It was 215. That gives us the 325, so the first equation checks. Then let's see, 9 times 110 plus 7 times 215 is $24.95, so we're good to go. So let's do our conclusion. So I'll do this up here. $110 adults and 215 students paid admission and we're good. Okay, so on to the next fun math problem, an investment problem. So Kelly has $20,000 to invest. As her financial planner, you recommend that she diversify into 3 investments. So Treasury bills, I'll just call them T-bills, that yield 5% interest, T-bonds that yield 7% simple interest, and corporate bonds that yield 10% simple interest. Kelly wishes to earn $1,390 per year in income. Also, Kelly wants her investment in Treasury bills to be $3,000 more than her investment in corporate bonds. So how much money should Kelly place in each investment? So we have 3 things going on. So in our analysis, we're going to have 3 variables to name. So why don't we'll just do them in order. Let X be the amount invested in T-bills. Let Y be the amount invested in T-bonds. And let Z be the amount invested in, what was it, corporate bonds? So we'll call them C bonds, corporate bonds. Okay, so let's see what we have. We'll do the translate to math over here. So our first equation, how much money does she have to invest? Good, $20,000. So the sum of those 3 amounts should be 20,000. And then we have the next statement is all talking about interest. So we need to make an interest statement about each of these. So the T-bills have 5% interest, so 5% of the amount invested. The T-bonds have 7% simple interest, and then these guys have 10% or 0.1 of Z, and all of the interest she wants to get per year is $1,390. Okay, so our third statement, Kelly wants her investment in Treasury bills to be $3,000 more than her investment in corporate bonds. So Treasury bills was X, so X will be Z plus 3,000. Okay so far? Awesome. All right, so now let's see. I think for this one, think what we should do perhaps is use substitution. So, thinking with this about this guy, I know that equation C gives me the ability to write x in terms of z. So if I look at equation A, I have that x, y, and z. I could plug in an expression for z into x, and then I'll have something I'll be able to isolate y in terms of z. So that's the game plan. We want to get both x and y written in terms of z. So let's do it. So when we solve, we'll have our first step will be, the first step is to substitute x equal to z plus 3,000 into equation A. So equation A was x plus y plus z is equal to 20,000. Plugging in z plus 3,000 for x, we'll have this. So z plus 3,000 is what we plugged in for x. So now I'll have y plus 2z's is equal to 17,000 when I subtract 3,000 from both sides and combine the two z's. And then isolating y, I will have y equals 17,000 minus 2z. So what I'll do now in the next step is, or what we'll do now, we're going to substitute the x equals z plus 3,000 and the y equal to 17,000 minus 2z into equation B. So equation B was what? Oh, the interest stuff. So equation B was 0.05 times x plus 0.07 times y plus 0.1 times z is equal to 1,390. So 0.05 times z plus 3,000 plus 0.07 times 17,000 minus 2z plus 0.1z equals 1,390. So, I want to be consistent in the colors I was using. For X, I usually always do the blue. Let's do that. So X was this, and then, so we'll have that again over here. And then Y is this. That's what we found in the last step. And now we're going to be looking to solve for Z. So 0.05 times Z plus, I believe that'll give us 150. Yeah, 10% of 3,000 is 300, and half of that is 150. And then plus, I think we'll have 119, maybe. 7 times 7 is 49. Yeah, 119. And then I think it'll be 1190. because 10% of 17,000 would have been 1,700. So I think we're good there. And then 2 times 0.07 is 0.14 times z plus 0.1 z equals 1390. So then we will have, when we combine all the z's, the first one and the very last one, 0.05z plus 0.1z is 0.15z. And if I take away 0.14z, I will have, I think, 0.01z. And then, let's see, we're going to be getting the constants to the other side. So we'll have, so let's double check the math on what I did before. 0.05 plus 0.1 minus 0.14 is 0.01. We're good. All right, and then we're going to be taking 1,390, and from that we're going to subtract 150, and we're also going to subtract 1,190, and we get 50. And when I multiply both sides by 100, I'll get 5,000. So z is 5,000. Now we can back substitute in the other expressions to find x and y. So substitute z equals 5,000 into equation C. We'll solve for x. So x is equal to z plus 3,000. So x will be equal to 5,000 plus 3,000. That's what we had found for z in the last step. So that gives us x is 8,000. And then, we can just go back to the very first equation. What was our step 3? Our very first equation to find y. So we have substitute x equals 8,000 and y equals 5,000 into equation A, and we'll solve for y. So x plus y plus z equals 20,000. 8,000 plus y plus 5,000 equals 20,000. So y will equal, what is that, 13,000? So 7,000. So we plugged in z was 5,000. X was 8,000. So now we have y as 7,000. So our conclusion will be who is this? Kelly. So Kelly should invest $8,000 in T-bills, $7,000 in T-bonds, and $5,000 in corporate bonds. And we're done. Okay, moving right along. Um, so next we have a motion problem. So let's see what we have going on. So the average airspeed of a single-engine aircraft is 150 miles per hour. If the aircraft flew the same distance in 2 hours with the wind, so it has a tailwind, as it flew in 3 hours against the wind, what was the wind speed? So let's check it out. So distance equals, great, rate times time. So let's see, if we make some, if we let x be the rate of the wind, because that's what we're wanting to find. And I always find in these problems it's easier to make a chart. So we have with the wind, we have against the wind, and we have that rate times time equals distance. So when you have a wind pushing you from behind, so you're with the wind, you're going your rate in still air, which they gave us is 150, plus the rate of the wind. And conversely, when you're going against the wind will slow you down. So you'll take away the rate of the wind. So with the wind, how many hours were we traveling? Great, 2 hours. And against the wind, we traveled 3 hours. And the distance was the same distance. Okay? So now, when we go to translate to math, we'll have rate 150 plus x times time, which is 2, equals our distance. And then we had 150 minus x times 3 was equal to our distance. So this one will end up being 300 plus 2x equals our distance. And this guy will be 450 minus 3x is equal to our distance. So here you have the same distance equal to two different expressions. So what we're going to do when we solve it is we're going to set the two equations equal to each other. Actually, we should say set the left-hand side. Can I say LHS for left-hand side of each equation? And we'll just say equate. That'll be nice. All right, now we've got it. So we had 300 plus 2x will be equal to 450 minus 3x. So I'm going to add 3x to both sides to get 5x. And I'm going to subtract 300 from both sides to get 150 on the right. Dividing by 5, we'll have x is equal to 30. So our conclusion will be the rate of the wind is 30 miles per hour. And that would be probably the average rate of the wind. And you're all set. How you doing? You hanging in there? Aren't you glad I broke this lecture up into 2 parts? Okay. I think this guy's our last item on this section. So find real numbers a, b, and c so that the graph of the function y equals ax squared plus bx plus c contains the points given there. So this guy's a little different. So the first part will actually be sort of the analysis and solving. Analyze and translate to math. Because what we're going to need to do is we're going to need to plug each ordered pair into that general equation, and we'll end up having unknowns of a, b, and c instead of what we're used to having unknowns as the y and the x. So here we go. So our first one, so we'll just put the general equation up here. So our first equation, if we plug in the first order pair, -1, -2, we'll get -2 in for y and -1 in for x. So I'm going to basically, this is where the x's are, 3 times I'm going to do this. So we have our y was the -2 for this one. And then this is going to give us, I'll switch it around so that I'm going to swap the sides of the equation. So we'll end up getting a minus b plus c equals -2. Now for our second one, we'll have, good, -4 is equal to a times 1 squared plus b times 1 plus c. So again, here's what we plugged in for y. This is what we plugged in for x. So we'll end up getting a plus b plus c equals -4. And then our last one, 4 is the y value and 2 is the x value. And we'll get 4a plus 2b plus c is equal to 4. Okay, so far? Awesome. So solve. Let's take a look. I kind of would like to work with I kind of want to work with eliminating c. Remember, you got to eliminate the same variable twice, and the c's are going to be easy because we'll just have to multiply by a negative. So our second step in this one will be to solve the system. So here we go. If we name this guy A, B, and C, what we'll do is I'm going to say negative. So our first step will be negative A plus B, and we're going to eliminate C. Actually, that's the small c there. So when we do that, we'll have negative a. I'm going to swap all the signs in equation A. So I'll get negative a plus b minus c is positive 2. And then I'll have a plus b plus c is negative 4. Oh, so it looks like we're going to luck out because the a's are going to zero out as well. So we'll be able to solve directly for b. So b is going to end up being negative 1. Okay, so now our second step will be to, let's take a look up. Why don't we go ahead and do we know what B is. So let's go ahead and we'll just eliminate. We'll do A minus C this time, or negative A plus C is safer. So we'll do negative equation A plus C. Again, we're going to eliminate C. So negative A was, we already had it up there. And then C we left alone, so equation C was 4A plus 2B plus C was equal to 4. So we'll get 3A plus 3B equals 6. But we know what B is, right? So what we're going to do is we're going to substitute B equals negative 1 into this new equation D that we formed. And we'll be able to solve for A. So 3A plus 3B is 6. Plugging in negative 1 for B, we'll have 3A plus 3 times negative 1 is 6. So B was negative 1. So 3A minus 3 equals 6. So 3A is 9 and A is 3. So we're making some progress. Now all we need to do is plug in what we have for A and B, and we'll get our value for C. So our fourth step will be substitute A equals 3 and B equals negative 1 into equation, let's just do equation B, that's a nice one. So equation B is A plus B plus C equals negative 4. A was 3, B was negative 1. We're finding C. So this was B. This was our A. So 3 plus negative 1 is 2. And taking away 2 from both sides, we'll get C is negative 6. So, conclusion. Actually, our conclusion will be our third step, not our. So, conclusion. We found that A was 3, B was -1, and C was -6. So if you put that together with the general equation, we'll have y is 3x squared minus x minus 6. All right, so that wraps it up for today. Have a fabulous evening, morning, afternoon, whenever you're watching this, and I'll talk to you soon. Bye.